Welcome to clickmyproject.com.
Project title is Workload Modeling for Resource Usage Analysis and Simulation in Cloud Computing. Now we are going to discuss about our process for abstract. So workload modeling enables performance analysis and simulation of cloud resource management policies, so which allows cloud providers to improve their systems quality of services and researchers to evaluate new policies without deploying expensive large-scale environments. So however, workload modeling is challenging in the context of cloud computing due to the virtualization layer overhead insufficient available for analysis and complex workloads. So aiming at the current problems that most physical hosts, it's the cloud data centers, are so overloaded that it makes the whole cloud data center so load balanced, and that existing load balancing approaches have relatively high complexity. So in this paper has focused on the selection problems of physical hosts for deploying request task and proposed a novel heuristics approach called load balancing on BIOS and clustering like LB and BC. So most previous work generally utilized the series of algorithms through optimizing the candidate target host within an algorithm cycle and then picking out the optimal target host to achieve the immediate load balancing effect. However, the immediate effect doesn't guarantee high execution efficiency for the next task, although it has ability in achieving high resource utilization. So based on this argument, so load balancing based BIOS and clustering introduce the concept of achieving the overall load balancing in a long-term process in contrast to the immediate load balancing approaches in the current literature. Let's discuss about our process flow diagram. So first of all, we have to create data center, data broker, virtual machine and cloudlets of virtual clouds with the help of CloudSim simulator. So a data center is a facility used to house computer systems and associated components such as telecommunications and storage systems. The next we have to create data brokers. So and data broker or information broker collects information about individuals from public records and private resources, including census and change of address records, motor vehicle and driving records. User contribute materials to social networking site. So thirdly, we have to create virtual machines. So virtual machines is an emulation of computer system. So virtual machines are based on computer architectures and provide functionality of the physical computer. Their implementation may involve specialized hardware or a software or a combination. Okay, so finally we have to create cloudlets. A cloudlet is a mobility enhanced small scale cloud data center that is located at the edge of the internet. So the main purpose of the cloudlets is supporting resources intensive and interactive mobile application by providing powerful computing resource to mobile device with low latency. So after creation of all things, we have to calculate the overall loads. So here we have to calculate the overall loads with the help of load balancing, BIOS and clustering. So then next process is priority assigned for all jobs. Here we have to indicate the jobs is let us the cloudlets. So that is the base of an ant colony optimization is the popular SI techniques in cloud by taking into accounts job priorities. So specifically we formulate our problem as minimizing weighted flow time of a set of jobs. The weighted sum of the job finish times minus job start times. So while also minimizing make span time also. So our scheduler essentially includes a cloud-wide like a virtual machine and allocation policy based on the ACO like on colony optimization. So with the help of this algorithm we have to assign the priority wise for all jobs. So finally the process we have to comes the end, that is called evaluation results. So here we have to find out the flow time of the job and max spans time and queueness. So these types of performance parameters we have to calculate it. Let's see the demo of our process. So load balancing is the title. Go to the inside of load balancing. Run with home.java. Just click right and give run file. So it's running. Workload modeling for resource usage analysis and simulation in cloud computing. So this is our title. Just click this button. So cloud environment creation. First of all we have to create the data center. I give file, click OK. 5 data center will be created successfully, and it we have to create data brokers. I have two data brokers, so it was created successfully. And next virtual machine and cloudlet creations. So just to click that virtual machine, I have to give 5 virtual machines, so it will be created successfully as per the cloud brokers. Then finally we have to create the cloudlets, which is called as job. So I have to create 20 cloudlets, so 20 jobs will be calculated. Then click next button. So here overall load balancing, just to calculate the overall load balancing, which contains the virtual machine ID, bandwidth, RAM, MIPS and number of PES. So relatively the virtual machine ID is changed as the host ID, so we have to allocate on the virtual machine. So proceed. So virtual machine host and using Navier-Bayes algorithm. So using the Navier-Bayes algorithm, the virtual machine can balance their load, okay, and host also balance their load wise. Next click proceed. So this is the host for VM. So relatively ID, host ID is relatively to the virtual machine ID. Then cloud balancing, so we have to create 5 clouds. So related to the clouds we have to allocate the input jobs. So allocation will be carried out. Then click proceed. So task priority VM manager allocation. So finally the execution time will be calculated for each cloudlets, which containing the virtual machine ID also. Then click to next. So waiting and flow time calculation, just I have to click the calculate. The total jobs or cloudlets is 20. This is the flow time for each cloudlets. This is the max spans time and queueness of the process. So click performance graphs. So this the first graphs is intimate the response times of the process. So in x-axis taken as a number of cloudlets, which is called 20 cloudlets, I think so. So in the red color intimate the existing system, and the blue is proposed system. When compared to existing system, the running time is less. Okay, this is the response time graph. Then next, performance of and colony optimization with following parameters. So the red color indicates this is broker cost, and this is time duration, this is bandwidth and RAM speed, this throughput and overall cost. So with the help of and colony optimization, the parameters should be like that. So this is the flow time for each job. So I will show this flow time on pie chart. So each and every cloudlets having the particular flow time. So demo is completed. Thank you for watching.